Shraddha is there. One second, let me make her a co-host. Okay, from your end, all the coordinators, track coordinators are there. Can you just check?
Yeah.
I see track 4 Minimol is there, track 3 Vishwas is there, track 2 Shrestha is there, and you're there in track 1.
Okay, I hope track 4 they'll be starting with physics. I hope Navneeta or Anupriya, one of them, has also joined.
I don't see them. Do any of you see them?
Mini, they'll be joining, right?
Ask Mini to check.
I think we can start segregating now, the breakout rooms.
Okay, yeah.
Meanwhile, Dr. Sheena can start. Then I will give a brief of what we did in the yesterday's transdisciplinary. Dr. Sheena?
Yeah, we can, Professor, just a quick note, you may want to take off your video if you're having internet difficulty.
Okay, is it on? Okay, yeah. I'm seeing only the big screen with the only files, NADK and CSD and all that. The video was there. Okay.
Okay, so good morning to all of you. The final day of the FDP. Thank you once again for all of you who have joined us today on time, and our sincere appreciation for all of you joining every single day regularly on time. We never had anybody who come and delayed. So the agenda is there for us. It's predominantly the breakout session presentation. The presentation, project presentation in individual breakout rooms. So I think all the other things remain the same. Just a quick note, the valedictory function, we will have it at the end of the day as we end the session. So I would be requesting all of you to turn on your video for a quick picture. That's the requirement from my end. I hand it over to Dr. Sheena to start the session. Sheena?
Okay, if she's away, I'll straight away take up.
Yeah, yes, please.
She was here. Yeah, very pleasant good morning to everyone, the participants. Hope you have been enjoying the FTP program. We try to pack in things in such a way that as we are moving towards new national education policy, which demands interdisciplinary and transdisciplinary work. So let us be ahead and start doing it as soon as possible. So that's what we packed it in this. It is not just the virtual lab alone, because as a PALS partnering institutions, we wanted to give rich experience in such a way that we are able to give you a feel of what is coming ahead, and not just on the online class and online laboratory. So in that way, first 2 days we put all the subjects of basic subjects together and demonstrated. That was also a test for each one of us to see how well we are able to at least listen and appreciate other branch of studies, and are we able to cope with, and just even if you are not full attention, if you listen, are you able to go along with that subject, was the test kind of a thing which we did in the first 2 days. Then third day you went on to the breakout room, and the fourth day you had an transdisciplinary work which Center for System Design is doing. In fact, each of the work which Professor Prithviraj has shown to you have a storyline. Hope we will get some chance wherein I will start with the storyline, how each work has started, and what was the problem statement, and how did we come back to a technical solution. So each of the work which Prithviraj presented literally have a storyline, and the problem statement was altogether different. Some of the cases it was from zoology or biology or forest or conservation, things of that kind. Finally, we came to technological solution. So with that basic introduction, basic note from my side, I would like to get going with the presentation in the breakout room. Anything else, Beryl, you like to add?
No, sir. I hope everything with regard to the project presentations is clear to all the groups and all the participant teams. So we would request you all to stick to the timelines that have been specified in the group. In the case of group track 1 and 1, we have 6 groups. In track 2 and 3, we have 5 each, and track 4, we have 4 groups. So accordingly, the time limit for each group for in each track would have been specified to you. Please stick to the timelines and make sure we are able to come back to the main room by 12 o'clock as scheduled. So all the best to all the faculty members for the presentations.
Dr. Sheena is there. She might want to say something.
And also Krishnamurthy sir, if something has to be very specific.
RKR, I didn't find him.
Yeah, RKR, I am able to see him. Not only the video itself.
One second.
Now I understood how to make the video also to be available, because if you put it in full screen, only the presentation is coming.
Yeah, so he's just joined.
Yeah. Oh, he cannot unmute.
Yeah. Good morning, RKR. Sorry about I did not spot you earlier.
Yeah. Good morning, everyone.
Good morning.
So you are on the final day. We are on the final day of this session. We hope you had an interesting 4 days. And as Dr. Gangadharan has said, I also fully agree with him. And I reiterate the point that going forward, it is going to be the age of multidisciplinary work. Somebody asked, what is the difference between interdisciplinary, multidisciplinary, transdisciplinary? So, well, there are a lot of fine, if you look at it with a fine toothbrush, there could be differences in how it is done. But I would say that overall, it means that people of multiple disciplines, people with multiple skills have to come together and work towards solving societal problems or business problems. So that is what is the requirement. Of course, the finer aspects can be looked at and worked out separately case by case, as these words show. But the bottom line is this, and I would say it is not just the engineering branches, but going forward it will also be branches of non-engineering disciplines also will come together. We will see people who have done probably some fine arts courses joining with a team of engineers and developing something to a product to solve a problem. So these are not new things. These have started happening now. So when we are moving into this new age, I think at least the least or the first step that we expect our faculty to do is to have an appreciation, have an openness towards other branches of engineering, see how they can understand what is going on there, how they can work together, and how they can develop solutions. Maybe starting with the lab experiments, you can go to bigger, solving bigger solutions to solve the problems. So with that, I think I'll not take any more time. I'll leave it to you and wish you all the best for the final day. Please make a good presentation. It's a good opportunity for all of you to learn from about the VLabs and make a good start to your gaining knowledge of the VLabs. Thank you.
Sheena ma'am, you have anything to say?
No, ma'am. I have heard everyone. I think that should suffice. Thank you.
Yeah, thank you. So, Beryl, do we get into the breakout room?
Yes, ma'am. It's 10 o'clock already. So I think we can move into the breakout rooms.
Yeah, I'm all ready. I'm just going to open it up.
Okay.
I'm just assigning the NITK people. Sreshta, Acube. Acube is not there. Shraddha.
Ma'am, will there be people to record the sessions?
Yeah, track 1 I'll be recording, ma'am. Ma'am, track 1 I'll be recording. In 2 Sreshta, 3 will be Robin, and 4 will be Minimum.
Okay. No, because today I don't know, my network is a little unstable. So in case I have to do, I shall do. I was just inquiring.
No, ma'am. I think we have
presently.
we are covered right now.
Okay, okay, okay.
So, Professor KVG, RKR, and Dr. Sheena, where would you like to go?
I will start with the first room, ma'am.
Okay,
Yeah,
Professor
I'll
KVG.
start with room number 3.
Okay, room number 3, Professor KVG, RKR. Okay, I'm opening all rooms. There are few people who have not been assigned. I'll
Okay.
call you out. Karthikeyan, RKR, and Subbalakshmi Radhakrishnan. I do not know which department, ma'am. Karthikeyan Karun, Subbalakshmi Radhakrishnan. I don't know which room. Professor Ganeshan from Nanda, I put you in breakout room 4. All the best to all the participants. Anusha, can you please come out of the breakout room? Anusha from NITK, can you come out of the breakout room so that I can make you a co-host? Yeah, just give me a second. Yes, I made you a co-host.
I think all the participants from mechanical department has joined. Uh, please make sure all the participants from civil is also there. So I think only 1, 2, 3, 4, 5, 6 civil people I am able to see.
We can wait for a minute, then we can start, sir.
Yes, sir.
Sir, I think you can start now.
Is mechanical M1 batch ready for presentation? Hello. We'll go in order like M1, M2, M3, and Civil 1, Civil 2. I request people from M1, please present your presentation.
Hello, am I audible? This is Srinivas Rao from Alpha College of Engineering.
Yes, sir, you're audible.
Okay, I'll be sharing my screen from M1. I'll be presenting this.
Yes, sir.
Okay.
Yes, sir. I am also ready, sir. Srinivas, sir. This is Paramasivam.
Yeah. One second, sir. Let me just share the screen. Why am I not getting? Okay. Now, I hope you can see the screen.
Yes, sir. It is visible.
Okay, good. Where is my play? Okay. The group, we have a mentor, Mr. Vishwas is our mentor, and the group has 6 people. Myself, Srinivas Rao, Kavita Madam from Alpha College of Engineering, Mr. Muthu Krishnan from KIT, Mr. Ramchandran from KIT, Mr. Arivamani Ravanan from KIT, and Mr. Paramasivan from the Rajalakshmi Institute of Technology. Now, the lab that we had chosen is Mechanisms and Robotics Lab. This is developed by IIT Kharagpur under a mechanical engineering branch. The Mechanisms and Robotics Lab is chosen because the future applications will be robots, and the mechanisms that are supporting robots are also very important, and they form the backbone of robotics. That's why we chose this particular topic. And these are also applied in many other applications. And the simulations that are there in this lab are working fine, except a few errors. Or most of the experiments are working very good. So that's the reason we have chosen this particular topic. Now, the team has chosen the following experiments to work with. I chose quick return mechanism. Madam Kavita chose old ham coupling mechanism. Muthu Krishnan has chosen cam follower mechanism. Ramchandran has chosen KGP50. Arivamani Ravanan chose forward kinematics and move master RM501. And Mr. Paramasivan have chosen forward kinematics of Puma 560. These are the experiment details. I'll just quickly complete my presentation, and then I'll ask the others to participate. I have taken quick return mechanism. Now, the quick return mechanism converts a circular motion into linear motion. That's the basic purpose of this particular mechanism. The specialty of this mechanism is that the return stroke is faster than the forward stroke. And because of this, it is applied in many mechanisms like presses, shaping machines, and other machines. It is applied very much. The aim of the experiment is to understand the working principle of this particular mechanism. Now the process in this particular lab, we can look at the complete picture of all the elements in 3D we can look at. We also can move the slide, the crank, so that we can see all the mechanisms moving interrelatively, and it gives a complete picture of this particular topic. Except for that, it doesn't run automatically. Though the functionality is shown that it can run automatically, it is not running automatically, except that we can see everything in this particular experiment. Now I'll try to play this video, what I've generated. 1 second, let me just. I don't know whether video will play here or no. I don't think the video is playing. I'll play the video from our other. Not happening.
Hello, sir.
Yeah, I'm just playing it. 1 second.
Okay. Actually, video playing is not necessary. Just
okay.
Short term of explanation is sufficient, sir.
Okay, then I'll stop this and I'll hand over to Madam Kavita. 1 second.
Okay.
Sir Srinivas, sir. Good morning, everyone. Can you please share the same screen, sir? PPT screen.
Yeah,
I'll continue it. Yes.
Yeah,
sir.
I'll just share, madam.
Thank you, sir.
Yeah, let me just open it, madam.
Yeah, thank you, sir.
So press F5.
F5. Not going up, I don't know.
I'll otherwise
okay,
downstairs it will be there. That one button is there, slideshow. In the right side down.
That also.
At the top there is okay.
Yeah, I think we are on. Go ahead, Madam Kavita.
Thank you, sir. So I'm R. Kavita from Alpha Engineering College, assistant professor, and I'm going to discuss about Oldham coupling mechanism. It's a third inversion of double slider crank chain, and which is obtained by fixing the connecting link in between the two sliders. It is used to join two shafts which have lateral misalignment. That is, it's not collinear, it's not in the straight line axis, center is not in the straight line. So for power transmission, we use Oldham coupling, and this mechanism is applied in robotics and also in printer and copy machines. Aim of this experiment is to understand the working principle of the Oldham coupling mechanism. So can you go to the next slide? Thank you, sir. And this here in this particular V lab, we have seen the simulation, and it is clearly visible, and it shows the two sliders sliding on a vertical and horizontal slot when the input driving shaft is rotated, and also connecting link which is fixed in between the slider. output speed, sliding speed is calculated using the value omega of the input driving shaft in the simulation. So simulation has features to rotate the mechanism in 3D space as well. There is a progress bar, or there is a point or button which is used for rotating the input shaft. Sorry, I couldn't present the link for the presentation here as it was very big. Thank you, everyone. Can I? Okay. Thank you, sir.
Good morning to all. Am I audible?
Next person can follow.
Good morning to all. Am I audible?
Yes, sir.
Yes, sir. You are audible. A little bit clarity is required from your voice.
That voice is low, sir. Can you?
Now is it okay, sir? Hello?
It's low only, sir. So can you put the mic near to your mouth?
Yeah.
Or
Okay. Good morning to all. I am Dr. Muthukrishnan from Kalainar Karnataka Institute of Technology, Coimbatore. Today I am going to present about the mechanism of cam and follower. Okay. Cams are mechanical devices which are used to generate curvilinear or irregular motion of mechanical elements. They are used to convert rotary motion into oscillatory motion or oscillatory motion into rotary motion. So here it consists of three elements. The one is a driver member known as cam, and second is a driven member called as follower, and a frame which supports the cam and guides the follower. So the procedure here is it is a simple simulation technique. There is no experimental available here. It is a simple simulation that is given presented here, and here the procedure is you have to apply given the value of shaft driving speed omega within a suitable range, and then click OK to get the output sliding velocity of the slider. So we can drag the slider to see the motion of the mechanism at a particular speed. Then also the view can also be rotated about the point by keeping the left mouse button pressed and rotating its mouse. Okay, so for given for full 360-degree rotation, we can see the movement of the cam and the follower in this simulation. So this is the schematic representation of the cam is given here, and the simulation is presented here. The link is given in the video link. So this is all about the cam and follower mechanism. Thank you.
Good morning, everyone. Am I audible?
Yes, sir. Yes, sir.
Yes, sir. Very much.
Okay, sir. Now I'm going to present the introduction about KGP50, which is an industrial prototype robot. And this robot has been available for transferring technology and for education purpose. And robots has been planned to use in development of intelligent driver vehicle interaction simulator. In order to have a driving mechanism, the thing over here is we need to have control for a number of axes. Over here, this consists of 6 axis operations, and it can able to withstand a 50 kg payload, which can able to have a reach of 1.5 meter, and it can able to make a maximum speed of 1.5 meter per second. So these are all the initial specifications about this thing, and using this, we can able to obtain, or we can able to move according to our wish, because the maximum degree of freedom available over there is 6 degrees of freedom. Over here, we are using all the 6 degrees of freedom in order to obtain the maximum. Over here, each and every axis can able to be rotated, and each and every axis are having, can I share another one screen which consists of the diagram? Because without the diagram, it is a bit tough task for us to explain about it.
You can.
Okay.
Go ahead, please share.
Yes, sir. Yes, that's what I'm doing. Can you able to view the screen which consists of the
No,
axis
not yet.
diagram?
No, sir, your screen is not being shared right now.
Okay, 1 second, sir, then.
So you can use your share screen option to share your
Yes, sir.
screen.
1 second. Now, can you able to
No,
view
sir,
the
not
screen?
yet.
No, not yet.
No.
Not yet. Okay.
Yes, now.
Now I think we can see the screen.
We can see your screen.
Okay, sir. Can you able to view the screen now, sir?
Yeah, yeah, we are able to see now.
It consists of this robot consists of 6 axes. First one is vertical axis, and after that it consists of axis 2 will be available over here, which can able to make a rotation in this area, and third axis is available over here, and the fourth one is available. You can able to rotate this, and the fifth one you can able to rotate this, and sixth one you can able to turn the a rotary slot which can hold a tool. So in this way we can able to make 6 operations, 6 rotations, so that you can able to achieve to any extent, to any point. It is like a 3D thing. You can able to achieve any point, and you can able to do any kind of task using this 6 axis. So if you are effectively utilizing, you can't able to make everything to be work at the same time, because it's a very tough task for us to make it. So that first we can try the first axis over here, this axis. You can able to rotate it to the position, and then you can make the utilization of the second axis, and then you can make utilization of the third axis, and then you can make utilization of the fourth axis. Each and everything can able to be controlled over there. If you are viewing the animation video, can able to get how it is working, so that you can able to achieve anything. You can able to reach any point in the space within the given reach. That is the major advantage of it. If you are effectively utilizing that, you can able to achieve a lot of things. Even for the COVID and all those things also, we can able to use this kind of arms as a thing. Can I display the video needed?
No, that's okay. I think they will privately see the video. Okay.
Okay. So
We have a time slot, like 5 minutes left. Within that, your team has to complete the presentation.
Okay, sir. Okay, sir. I'll move to the next person.
Mr. Arivumani Ravanan, please continue.
Sir, is it audible for you?
Yeah, you're audible. You're audible.
Yeah, fine. Hello to everyone. I am Arivumani Ravanan from KIT Kalaignar Karunanidhi Institute of Technology, Coimbatore. My presentation is about the simulation-oriented experimental exercise of an articulated trainer robot named Mitsubishi MoveMaster RM501. Actually, this is a basic level industrial robot with 5 rotational joints having 5 degrees of freedom. That is one concept we are using here, forward kinematics. It refers to the use of the kinematic equations of a robot to compute the position of the end effector from the specified value for the joint parameters. The kinematic equations generally we are using for the robotics, computer games, and animations. The essential concept for this forward kinematic animation is that the position of the particular parts of the model at a specified time are, is it audible?
Yeah.
Are calculated from the position and the oriented of the object, together with any information on the joints of an articulated model. When I'm talking about the construction, if the object is animated is an arm with the shoulder remaining at a fixed location, the location of the tip of the thumb would be calculated from the angles of the shoulder, elbow, wrist, thumb, and knuckle joints. 3 of these joints, like that shoulder, wrist, and the base of the thumb, have more than 1 degrees of freedom, all of which must be taken into account. The working axis, the degrees of freedom, all such things have been explained in the previous slide by the Professor Ramakrishnan, so I don't want to get into that topic in much. If this model were entirely human figure, then the location of the shoulder would have also have calculated from the other properties of the model. When we are discussing about the objective and procedure, the main objective is identify the geometrical relationship between the input and the output motion parameters of this robotic arm. And the next objective is formation of the transformation matrix through which the relationship is established, that is between the link and the manipulator. And we can get the better idea about the workspace through the 3D graphical representation plot of there is one manipulator position now we are using based on the input. What about the manipulator position? Such things we can find in the animation video. Also, one of the objectives is simulate the robotic motion for various inputs of the joint angular value. The procedure is inserting different values of the theta within the joint ranges as prescribed by the product makers or the theory. Then if we put the click OK button, we can get the output orientation and the position of the end effector through the transformation matrix on the manipulator position screen. To see the individual movements of this link, drag the sliders on the control panel. The manipulator position, also it just now I told you, it shows the 3D graph for every submission of the joint value. The left button, middle button, and right side button functions have given in the simulation video. When you are looking at them, you can understand. When I comparing this motion of a real robot with the simulation, when comparing the motion of the real robot and the simulation exercise, 3 better merits we can achieve. One is proof of concept and proof of design. The main advantage of the robot simulation is that it provides proof of concept for the researcher and product developers, maybe from the student community, and proof of design so that the flaws are not built in the robotic systems. Proof of concepts and design ensures the best robotic systems installed, that it work just as intended. When you are discussing about the point reduce integration costs, the robot simulation helps to reduce overall cost of the integration, implementation cost, maintenance costs, and other inconvenience in upgrading this physical model. Also, shorter system delivery times, that is one of the advantages when you are comparing this with the physical model. The robot simulation aids in offline programming, where robot program is completed before it is installed. And the robotic simulation has many different advantages over our traditional CAD methods, but they all translated into reduced cost, shorter integration times, and a higher quality robotic system. That's what I mentioned. Please visit to the video. Please visit to that tutorial video through the given link for better practice and procedure through this MoveMaster RM Finite 1 simulator. I think the video demo is at working condition. If you click that, we can enter into that. Thank you for the opportunity given.
Thank you, Arivamani.
Yeah,
I think Dr. Paramasivan can take over.
So good morning to one and all. This is Dr. A. Paramasivam from Rajalakshmi Engineering College. The experiment that I have taken is forward kinematics of Puma 560. So kinematics is the study of relative motion between the links. So forward kinematics in the sense which is going to deal with the relationship between the individual joints of the robots, manipulators, and to determine the position and orientation of the end effectors. So that is the main objective of this experiments. So in this forward kinematics, we are going to consider the open chain mechanism. So if you are going to take the 4-bar mechanism single study, it's a closed chain. But here the robotic end effectors arms, it's going to be open chain. So that here we are going to move towards, from the base, we are going to move towards the end effector. So that only we are calling it as a forward forward kinematics. So Puma is nothing but programmable universal machine for assembly, for machine assembly. And in this, if you are going to take this machine is developed in the year of 1978 by Victor Sherman at Unimation. So there are various variations of Puma 560. Puma is available in various series like 260 series, 560 series, and 761 series. And the main aim of this experiment is to determine the position and velocity of the end effectors from the base. So if you are going to take, it is an industrial robot arm, which is going to have the 7 links, and it has 6 degrees of freedom, and all the joints are rotational joints. So here the joints are going to have the lower parts, and each and every joints is going to have some of the constraints in the term of maximum possible rotations. It's going to be 320 degree, and it's going to be 250 degree. So the base is going to be called as waist. The link number 2 is nothing but the shoulder. You can see here. This is the link number 3. This is going to be the upper arm. This is the link number 2, which is going to be the forearm. And at the end of this, we can see the various links like wristband and joints and wrist rotation and flanges. So based on this, we can pick and place the objects. And this application of Puma is applicable in the automotive industries, like in the automotive industry for welding purpose, and pick and place the object from the assembly or from the blanking operations. So these are the main applications of this Puma. So this Puma is it is mainly for accuracy, repeatability, and safety operations. We are going to use it. And by our teammates, they have proposed the proof of concept and design and accuracy. The same thing is also applicable for this. Yes, sir. That's it, sir. Thank you. So the video link is available in the IIT Pulse drive, sir.
Thank you, Paramasivan.
Thank you. Thank you, sir.
With this, we conclude M1's presentation. Thank you very much to all the participants and mentor, Mr. Vishwas. With this, I hand over to the next team.
Thank you, sir. That was well organized. Well done. Now, team M2 can present their screen.
Good morning to all. This is Gopi Vel. Am I audible?
Yes, yes.
Thank you, sir. So this is batch M2 from mechanical. I'm a team lead, Mr. Gopi Vel, and followed by our batchmates, Mr. Ravindran from Sairam Institution, Ms. Vinita from KIT, Mr. Venkatraman from KCG, and Mr. Prakash from KSRCT, and finally Dr. Ganeshan from Dr. MGR Education Institution. So our mentor is Mr. Vishwas. So we chosen a lab on dynamics of machines. So before going to the lab, I just want to tell some advantages of VLabs. So definitely it is a good initiative taken by MHRD. So we can remotely access the lab experiments at any place at any time. So definitely it will be useful for end users like students from UG, PG, or as well as research scholars. They can easily utilize lab at any remote access. So apart from that, for each experiments, the resources like video lectures, simulation, and pre-test, post-test, and all very good available sources for each experiment. So definitely the end user will get benefit using this VLab, and especially in this current situation. So with this, I move on to the lab which we have chosen, dynamics of machines. So dynamics of machines, it is used to study the basic motions on forces which are acting on the system, especially on dynamic system. So this kind of labs which is used to understand the basic concepts to design the robotic or vehicle dynamics, which will be definitely useful to analyze the forces which is on the system. So with this, the following experiments like governors, balancing, and disc type or flight type wheel, this kind of experiment which comes under this lab. So I have taken Hartnell governor. So basically the governor, which is nothing but it is used to change the speed of the system based upon the applied load. So this experiment with the aim is to visualize the working and the effect of speed change on the Hartnell governor through the simulation. So usually the basic difference between the Hartnell governor to the other governors is that it is actuated using spring. So the Hartnell governor is controlled by spring. So it is having crank levers, balls, frames, and all. So once the applied load, based upon the applied load, the speed gets increased so that the radius of rotation of balls get increases, and the roller lift the roller, I mean lift the sleeve against the spring force. So if the speed get decreases, the sleeve move downwards with the spring force. So it transmit the movement to the throttle bar. So based upon that, the fuel, I mean if we are taking automobile vehicle, based upon that the fuel injection takes place. So this is what basic concept behind the Hartnell governor. So using simulation, we have two variables. One is to change the mass, and other one is to change the speed. So based upon that, we can based on these two different variables, we can calculate the stiffness or stiffness of the spring, or we can get the distance of the lift, sleeve lift and all. So next one. So the basically the procedure behind this, we can change the mass in from 1 to 6 kg, and change the speed from 365 to 400 rpm. So there are two portion. One is minimum portion and maximum portion. So with this we can also get the free body diagram for the governor. So from this experiment, the user can able to derive the equation, governing equation for the system. Based upon that, we can identify stiffness equation, throttle distance, and the radius of rotation and all. So we can easily calculate based upon the manual calculations. So from the experiment page, we have taken a pre-test and a post-test and all. So definitely this will enhance the evaluation procedure for the students. So with this, I'll hand over the session to Mr. Ravindran. So Ravindran sir.
Thank you, Gopi sir. Am I audible, sir?
Over to you, sir. Yes, sir. Carry on.
Yeah. Good morning, all. This is A. Ravindran from Sairam Engineering College. So, thank you, Gopi sir, for organizing our team. So, I'm going to present the experiment on Porter governor. So, the aim of the experiment is to visualize the working and the effect of change of speed in the Porter governor through various simulations. So, moving to the experiment, here we can, a lot of experiments are there. So, one is part identification, and other one is working simulation. So, here the height of the governor with respect to the rotational speed can be calculated, and the length of the length of the arms and rotational speed of the spindle can also be examined. So to note down the minimum and maximum height of the governor with respect to the rotational speed, we can calculate. And this was the first time I have witnessed this virtual lab. So when I moving to the comparison between a virtual lab and real lab. So virtual lab, all the experiments can be performed virtually while staying anywhere without going to the lab. So with that, we can save a lot of consumables. Since we are doing a lot of simulations repeatedly, the students can able to easily understand the concept of that particular experiment. And next slide, please. So moving to the procedure, here in the simulation portion, the two right hand side tabs, it is available varying with the variations of speed and mass. By varying the speed and mass, the height can be generated. So the simulation portion is clearly shown that under which speed and under which mass, what will be the height of the governor, like that it is clearly explained in the simulation. And uh, we have to move the slider knob to the right and under the RPM and mass to see the change in the animation in the portal governors. There we can able to see clearly about the change of height and also. And here there is a show graph tab. By clicking this tab, we can able to see the clear picture of the graph. So where it will be height versus RPM. And for the experiments, we have to go to the experiment. So under the experiment, we are having two tabs. One is simulation and another one is part identification. So in the calculation part, there will be a constant variable, height and mass graph is given for calculation the mass. The calculation can be done using the formula which is shown in the right hand side, that is m square equal to m plus m by m into 895 by h. So based on this formula, we can calculate the speed, height and the mass. So like that, a lot of experiments we can do, and manual calculation can be checked with the simulation calculations. So that's all about this experiment. So I have shown the video link at the downward side. It will be clearly shown how the simulation is happened. So if time permits, I can play the video. Thank you, sir.
So next one is Vinita ma'am. Ma'am. Hello, ma'am. Vinita, ma'am. Are you there?
Hello.
Yes, ma'am. Ma'am, you please proceed, ma'am.
Sir, am I audible, sir?
Yes, ma'am. Yes, ma'am.
Okay, so in today's, so I'm going to present about dynamic analysis of slider crank mechanism. So in dynamics lab, so we know basically dynamics of missions lab deals with the study of motion of systems and the forces acting on it. So in that I'm going to present about the dynamic analysis of slider crank mechanism. So the dynamic analysis is nothing but the if the inertia forces are considered in the analysis, it is nothing but the dynamic analysis. So in this experiment, we are able to understand the analysis involved in the offset. We also able to understand the acceleration of center of gravity of the links and forces on each link of the slider crank mechanism. So as a slider crank mechanism is nothing but a closed loop mechanism, so which is a modification of a 4-bar chain. So and it has a single degree of freedoms. So we are able to calculate the forces. Sorry. So we are able to calculate the forces, accelerations, and the velocity and the forces acting on it. So, and using the procedures, the main aim of the slider crank mechanism is to convert the linear motion into a rotary motion. So as in its application is found out in reciprocating steam engine. So using the procedure. So next slide, sir. So using this VLab virtual labs, so there is a picturization of a position diagram, velocity diagram, and the acceleration diagrams. So there are the variables, so we can vary the mass M2, M3 and M4. We can also vary the angle between them. So using the control tabs, we can control the variation, we can pass and we can animate the videos. That is the how the rotary motion is converted into the linear motion. So and using this link, I have clearly explained about the dynamic analysis of slider crank mechanism. Thank you. Hello, sir.
The next person can take over.
Yes, ma'am. Yes, ma'am. Thank you, ma'am. So, I'm Venkatramanan from KCG College of Technology, assistant professor. I have taken the experiment of Coral Governor to understand how virtual is working. We found that this virtual lab is very useful for our students. We have given task for subjects like fluid mechanics, solid mechanics, etc. And students are very interested to learn of their own, and which makes them to study more and to make them confident enough in this subject. So today I have taken the Coral Corner. The aim of the experiment is to understand the working principle of it and to calculate the parameters based on the given details. So Coral kernel is basically used in balancing the speed of the engine. Right? It controls many parameters like important parameters like fuel injection, etc. So, we have in the virtual lab website, we have a very detailed explanation of the theoretical part with some part of the derivations, which gives us the final equation to calculate the parameters. And we also have procedure and a pre-test and post-test test for the students to gain much more confidence on this particular topic. So I have taken a simulation part. We have two different options in this particular experiment. One is to identify the parts, which is more necessary for the students if they want to write a descriptive type of question. The experiment of identifying the parts might help them. And the other part was the calculation. In the calculation part, there are different types of calculation. The one which I have shown in the bottom right corner is the given the details like FM by BM. The capital M is given, and of course the RPM and mass is also given. So what we are supposed to do is to calculate the height of the Coral curve. Now, in the video link, I have also shown the calculation part. I have made a sample calculation based on the given details, and I have calculated the height. And we also have a checkbox. The students can check whether the answer is correct or not. I found this experiment was very useful, and as a faculty, I studied it long before. It was a light eye opener for me to understand Coral Governor in a better way. I thank you for giving this opportunity. The video URL is given. The detailed explanation of the Coral Governor, I have mentioned it in the video. Thank you for the opportunity, Gopi. Next, let me request Prakash sir.
Audible?
Yes, sir, you are audible, sir.
Yes, sir. Myself, Prakash from K. Sangasamy College of Technology. Very good morning to all. Under DYM lab, I want to present an experiment rim type flywheel. First of all, you should know what is the flywheel. Flywheel is nothing but it's an energy storage device. When the flywheel stores energy, when the system having excess energy, when the flywheel release energy, when the system wants, that is the function of the flywheel. You first aim of the rim type flywheel, we have to calculate the moment of area by varying the mass and radius of the flywheel and compare the experimental value and theoretical value of moment of inertia. First of all, about that experiment, you should know structure of rim type flywheel. You can see the 3D diagram below. You have seen put it in that using simulation. In simulation part, we have varying the size of the mass of metal and the radius of the flywheel. We can calculate the moment of inertia by using a formula, both theoretical and experimental. Finally, we have to compare compare the application of rim type flywheel over disc type flywheel. So next slide, sir. So next slide. Yeah. In simulation part, you have screened the dialog box that is rim type flywheel. Under simulation, we can start that start button. The flywheel starts rotate. A spring which mass m which is attached at that spring axle spring. When the flywheel rotates, the mass which falls down and reaches the ground. The flywheel does not start immediately. It's some time to take start because due to moment of inertia. That moment of inertia we have to calculate. For theoretically, we have to calculate how we calculate, but the I equal to mr square. By using the formula, we have to calculate the theoretical value, where capital M is nothing but mass of the flywheel. and r is nothing but radius of the flywheel. We can calculate that value, theoretical value. By experimental value, there is a formula, that is I equal to m 2gh by omega square minus r square divided by 1 n1 by n2. You can see that dialog box, we can varying the two variables. One is r, another one is m. R is nothing but radius of the flywheel, and m is nothing but mass of the metal ball. We can two variables we can adjust. We can calculate the theoretical and the experimental value. uh, Once we can calculate by using that formula, substitute that theoretical value in that box, and calculate the experimental value and substituting that box, and then after submit it, you have checked the whether the answer is correct or not. Suppose there is comparing the two values, suppose there is error comes, you can redo the calculation, and we have to rectify where the error is comes. In real time experiment, only the values can be calculated, and the students can able to see the structure of the flywheel. But in virtual mode, we can varying the variables, that is the mass and radius. We can changing the variables, and we can calculate the theoretical value and the experimental value, and the students can easily understand the concept and do the experiment at any time, at any place. That is the beauty of a virtual lab for this experiment. In video link, I will share the simulation video of a rim type flywheel experiment. You can see that in that drive. Okay, thank you.
Ganeshan sir.
Hello, Ganeshan sir. Dr. Ganeshan sir. Hello.
Yes, sir, you are audible. Please speak, sir.
So I think Ganeshan sir is not in the list. I mean, the participants list.
He is there, sir. He has unmuted his mic, but we are not hearing him.
The voice is
Yes,
too low, I think.
Ganeshan sir.
Internet is not stable.
His audio is having some problem.
Just a minute, sir.
Hello, sir. Ganeshan, sir. Try switching your mic on and off once. Hope we can hear you. Thank you. We'll wait for a few seconds. After that, we can move to batch M3.
Yes, sir.
Gopiel sir.
Yes, sir.
Sir, phone பண்ணி பாத்தீங்களா சார்க்கு?
Yes, sir. He is not picking up a call.
Okay, sir. I think he might be busy. Sir, he has done the experiment, sir, and he has loaded the YouTube link also. I think Vishwas sir, we can take with the other batches.
Yes, sir. Thank you.
Okay.
I think we have some technical problem.
Yes, sir.
Okay.
So it's fine. So people have done the hard work. We'll go for M3. Well done, sir. Well organized. Thank you.
Thank you, sir. Thank you so much.
Sir, can you able to see my screen?
Yes, sir. We can see your screen.
1 minute, I'll switch on the full screen actually. How to do the full screen? Because I'm trying, it's not working. One minute. Okay, sir, I can continue as it is. After that, I can try to do that full screen.
Excuse me, sir. Excuse me, sir.
Yeah.
Yes, sir. Just to go to the top of that menu tab, home inside, and that you can see that slideshow. Slideshow tab. Just to pick that one. Just pick that one, and start the beginning from the beginning. Just pick that from the beginning.
Okay, thank you for your help. My name is Dr. Emal Wilson John. I am working in a Dr. MGR Educational and Research Institute. I belong to M3 team. Before introducing my team members, I would like to say thanks to IIT Pulse team giving a beautiful and good friends to me in the team. So first, I like to introduce my first friend in the team, Mr. Prem Kumar N. He is working in the Sairam group of institutions. And the next, my friend name is called Dr. Mr. Nandakumar K. He is working in MAMCAT. Then Mr. Jiva Shivalinka. He is also working in the same college, MAMCAT. Then Dr. Elil Moran. He is working in a MEPCO. And then final, my friend name is called as S. Aravind. He is working in a Rajalakshmi institutions. My mentor name is Mr. Rohit. He helped me a lot, so I would like to say thanks to him this moment. Me as well as my team members did a lot of discussion. Finally, we took strength of material lab. I'll tell you why we choose this lab, because most of the people telling this one is a fundamental lab, basic lab. But my perception is not like that. It's a basic, it's not a basic lab. It's a very important lab for the mechanical engineering student, not only mechanical engineering student, electrical student, aeronautics, automobile, robotics, civil student, almost all the engineering batch students, they are studying strength of material lab. So what is the need of the lab? What is the need of the strength of material? Because suppose if you want to make anything, for example, if you want to make a racket, or suppose you want to make a car, robo, or suppose you want to make a dosa tawa or chapati tawa, anything, we need material. So how do you choose the material? Suppose if you want to choose the material, we should know the property or quality of the material. How do you check the quality? So by the help of some experiment, that experiment which is available in the strength of material lab. So what is mean by strength of material? Strength of material is a knowledge which deals the relationship between the externally applied load and the effects on bodies. So already I said what is the necessity, even though I'll tell that one, to strength of material is to study the quality or properties of material, as well as is to design the structural components. And the virtual lab, IIT Pulse, I like to say thanks to the virtual lab, because here they done a good job. So particularly in the strength of material lab, what are the experiments they are given in the virtual lab that is related to our college syllabus, as well as our students are having the same course in the forthcoming semester also. What is the benefit of virtual lab for the students? Not only students, for teachers also. It's used to help to advance the stages of the experiment, as well as to increase the contribution of the student to the experiment. That's a very important thing. So other benefit of virtual labs are, it's a very safer, So less cost, no time limitation. 24/7 we can work the lab. So my friends, 5 more friends, they will be going to explain Brinell harness test, bending test, tensile test on mild steel, compression test on mild steel, as well as torsion test. I'll give the screen to Mr. Prem Kumar. He will explain how to do the Brinell harness test. Sir, Prem Kumar, sir, screen is yours. Please start.
Yes, sir. Thank you, sir. Thank you, Dr. Wilson. This is Prem Kumar from Sairam Group of Institution. Today, I am going to present about Brinell harness testing. There are different types of testings in harness, taking the harness. The unique properties of the Brinell harness testing is nothing but, the Brinell harness test, compared to others, having an indenter makes the deepest and widest indentation. This is for finding the hardness of different specimens of different kind. So now the hardness can be defined as resistant to indentation, and this is determined by having the depth of indentation, by permanent depth of indentation. So you have to give a load or a fixed force by the indenter, and there is the smaller indentation, even the smaller indentation, the harder the material. The indentation hardness value has been calculated by the depth it achieved. And the Brinell's hardness test method is used to determine the hardness defined in ASTM E10 standard. The major objective of this particular testing is to examine the deformation of the metal specimen when hardened steel has been pressed towards different load condition. And the indentation describes the, by using indentation, you can determine the properties of the metal. Okay, when now we are going for, sir, kindly change the slide, sir. Wilson, sir? Okay. So this is a very simple procedure. Pardon? It's a very simple procedure. The Brinell harness testing machine is having. Actually, before getting into the procedure, I will tell what are the integral parts of the mission. Basically, it is having a, supporting table and elevator screw, anvil, and in the backside of the machine, that is back end of the machine, there is a hanger suspended for load application. So see, in this particular PPT, I have been taken cast iron as a specimen, because the cast iron as a specimen by standard it is fixed P value. There is a load value is 3000 kg. So it's the test has been taken from 250 kg to 3000 kgs. Now the specimen is having a there is a wheel has been provided in the bottom end, because when when you are placing the specimen has to be placed on the table, and it has to be elevated by using the elevated screw, and up to the indenter has to touch the particular specimen, and it should be some small 5 mm gap between that indentation and the test specimen before application of the load. Okay, now you can see this, the steel ball during this period moves to the position of the sample and make an indentation. So the measured indentate diameter is taken in the two places by coinciding the 2 points of the reading by the optical microscope, which has been fixed at the top of the machine. And when the measuring the indenter, we can change the load. Basically, we can have the load by 250 kgs. Normally, the load is been the hanger. Without that, the plate and the rod will be weighs about 250 kg. That will also taken under consideration. So we have to add the 250 kgs equivalent weight. So you are given incremental weight, and you have to take different reading of cycle of reading trials up to the load equivalent to 3000 kgs. So this is a way you have to find out, and finally you can achieve the difference. That is a difference in the weight, and you can make a average of the weight, and each you can calculate the Brinell harness number that with using the hardness which obtained, and you can arrive the final result. final result. So the major comparison with the physical lab, which we are doing right now, is in a real time, the minor load application to the intender can also cause, see, when you are using the minor load, it can cause a permanent deformation in this case. So it will be very specific that very gradually you have to increase the rate, your loads. There will be a red color mark indication. So we have to be very much cautious. It should not be going out of it. So up to that, you have to make a very gradual increase of your load to achieve it. That is small gap found between this physical and the virtual lab. So and there is another thing is the hardness is expressed in macro and micro hardness level. The macro hardness level, you can see it is related to the resistance to larger volume displacement in the plastic deformation. And micro hardness level is hardness of material is microscopically a small volume. These two can be analyzed. That is depends on the grain boundaries, which has been of different material structure. So this is the way we have to calculate the hardness of this. Okay, I'm very much thankful for VLab people for giving this opportunity. Thank you, sir. Thank you. Thank you very much.
Sorry to intervene, Vishwas. This is Sujata here. Just wanted to check if Professor Dr. Ganeshan's audio is fine. Sir?
It is not audible when the presentation is happening.
Yeah, I in fact tested it in the main session. It was fine. I just wanted to, I brought him here. Dr. Ganeshan, are you there?
Yeah, I am here.
Yeah.
Are you able to hear me?
Yes, right now, yes. Vishwas, it's fine now.
I have given a chat message also to Vishwas. Okay.
Yeah. So sorry about intervening. I'm leaving the room. Sorry.
Mr. Nandakumar, sir, please continue.
Yes, sir. Yes, sir. Am I audible to all?
Yes, sir.
Okay. This is Nandakumar from College of Engineering and Technology. And my leader and one of my batchmate, Mr. Prem Kumar and Dr. Wilson, nicely said about that strength of material lab and Brinell hardness testing. So here in this session, I'm taken this torsion test on mild steel. So what is meant by torsion test? Torsion is a vibration of shear torsion, variation of shear, and torsion occurs when any shaft is subjected to the torque. This is true whether the shaft is rotating, such as a drive shaft on engines, motors, and turbine, or stationary, such as with a bolt or screw. The torque make the shaft twist, and one end rotates related to the other, inducing the shear stress on any cross section. Failure might occur due to the shear alone, or because the shear is accompanied by the stretching or bending. Here we are going to see there is how to conduct this particular torsion test by using this torsion machine. So we have chosen this all the images and the details. Now I'm going to explain from this virtual lab, because in this particular virtual lab they have nicely explained and nicely demonstrated, simulated the particular torsion test in a very nice manner. So that I have chosen the image also from their place itself. So about this torsion test, the purpose of torsion test is to determine the behavior and material or the test specimen exit when they twisted or under the torsion force. Aim to determine the mechanical properties of mild specimen under the torsion. So, sir, can you switch to the next slide? Yes. So for particular this torsion test specimen, we can find out the torsion. There is certain properties like yield strength, moment of inertia, modulus of rigidity, modulus of rupture. Those things to be find out in the followed by the 7 step-by-step procedure, which is clearly explained this particular virtual labs. In the first the procedure of first step, just to measure the diameter of the specimen. So which is by using this any of calibrator like either micrometer or this vernier caliper, we can choose the particular specimen to be prepared as per the norms for this particular torsion test. So after measuring the diameter, you have to measure the length of the specimen between the grips. So grip is to be placed in this particular. Sir, can you switch to the previous slide? Previous. Excuse me, sir. Wilson, sir. Am I
So
audible?
this one or
Previous one. My first slide. Yes, sir. This torsion testing machine.
Yeah.
There will be a two, sir. First slide. Again, you switch to the last one.
Yeah.
Previous. Yes,
Yeah,
thank you.
this one only.
Thank you. Yes. In this torsion testing machine, there will be a two different jaws are there. That is, one is fixed one. It is in the upper portion of the arm, and the second one is a movable jaw. It is moved by using this flywheel, so which is used to hold that particular specimen. That is, which is to prepare especially for this particular torsion testing purpose. Sir, switch to the next one.
This one, sir?
No, sir. Second slide. Previous.
Second slide, 6. Okay. Okay.
Okay. Thank you, sir. Thank you. Okay. After preparing those things, that is specimen and measuring the diameter and measuring the length of the specimen, we have to draw the longitudinal line over the particular specimen where the this torsional is to be going to be conducted. So because while drawing this this longitudinal line over the specimen, which is indicate how the particular twisting or torsional force is to be applied, how it is to be twisted, that we can easily find over this particular area, that is in the torsion machine. So after that, marking those things, these are the very primary steps. First step is the diameter measuring. Second one is the length of the particular specimen is to be measured. And third step is the longitudinal line marking over the specimen. After that, it is to be placed in this particular torsional machine. So it is to be fixed here. There will be two types of buttons are there. One is green and red. Green is to switch on the machine. Red is to be stop the machine. So once we switch on this green button, so it is load is to be applied gradually. This particular load, after applying this particular load, gradually it is to be taken the graph point. So where it is the load is to be taken, how the angle of twist, and where it is to be going to be rupture. Those things is to be that is recorded with the help of this graph. Sir, switch to the next one, sir. Okay. So after completing previous procedure, that is switch on and switch off, after applying this gradual loads, after those things, the graph is to be obtained. How the load is to be calculated, how the load is applied, and how the rupture point is to be occurred. In this particular graph, we will highlight the particular area for finding the our required data. So slope of the graph will be obtained like this. With the help of, we can find out the delta x, delta y, and slope. Those things, after finding these things, we can calculate the moment of inertia, yield stress, modulus of rupture, and modulus of rigidity. Then after calculating the data, we can enter here, then check the values. If it is accurate or which is related to the entered value, then it will be accepted. So this is a procedure of conducting this torsional test. Then it is nicely explained in this particular virtual lab. And thank you for the opportunity, and thanks to the leader and my batchmate. Over to the Mr. Jiva. Thank you.
Give us that, please.
Thank you, Dr. Wilson. Myself, Jiva Sivalingam, MAM College of Engineering and Technology, Tiruchirappalli. First of all, I want to few words to share about a few things, because I don't know about the lab, because no one time I not handle this lab. I learned this lab here itself only. So what I understand, I'm going to share you. If you find any mistakes, kindly forgive me. Okay. So now I'm going to start about the bending test on mild steel. So bending test normally conducted for tensile strength for the material. Here I am conducting bending test on mild steel. Generally, mild steel were used on concrete structures like column or beam. Basically, this test is carried out by UTM machine. UTM means Universal Testing Machine. This bending test used to find deformation or deflection under applying varying load. When applying load continuously or gradually increase, we can easily find the deformation, and where it is formed deformation at under varying load. there are two types of bending tests. The first one is 3-point bending test. The second one is 4-point bending test. Here I conduct a 3-point bending test. So what is my objective? To study the behavior of mild steel rod subjected to gradually increasing applying load on equally on the specimen. So I'm going to explain about the procedure. So first we take the apparatus. So what is the apparatus mean? The UTM machines. So scale, steel scale and vernier calipers and 3 numbers of dial gauges. Okay. So first of all, take a vernier caliper to measure the diameter of the specimen in both sides. So take a steel rule to measure the length of the specimen. Then manually put the marking with the equal space interval. Now the next experimental virtually to prepare an already in VLAB. After finish the marking to fix the specimen on UTM machines. When virtually start the machine to apply the load gradually, it become to 40, 50, 100, 150 or 40, 80. So this kind of intervals to apply load gradually and continuously to given to the machines. So the other side, the reading will be displayed on the screen. So whatever we are applying load, there will be displayed on the on-screen projector. Next. So the reading will be taken as minimum 12 level to or 14 level. So after completion, applying load, when we apply the stop button, so the virtual machines given to the full readings of the machines. So the graph will be displayed on the on screen on another side. So the next one is the screen will be displayed dial indicator with applying load. So the next mode is the calculation mode, and manually enter the value. It will be displayed whether it is correct or not. So this is the procedure of applying the to conduct the experiment on the bending on mild steel, bending test on mild steel. So this is the actual procedures. So I am going to comparison with the physical lab experiment. This is the online simulator. So everything will be displayed on simulation motion. So it can easily understandable. So the calculation is very, very easy because the equations or definitions and formulas, everything it will be displayed on the theory mode and procedures mode. So the main thing is no need to stationary pencils or scales, rubbers, etc. Because on screen as it has already it's available. So no need to raw materials and hydraulic machines, and everything will be virtually and simulated on the virtual lab. So redo experiment. So some students has been missed on the class. So someone students has forget or anything. So can easily redo the experiment at any time, at any places. So who are all having Android phone, they can practice is very, very easy. The main thing is no need instructors and no need faculties, because the theory mode and introduction notes will given the very clear definition and clear explanations. So because when I am also compared between, I am also the student, because hereafter I don't know about the lab. So how I am practice means, first of all, I read the theory and follow the instruction and follow the procedures.
Hello, sir. Sorry
Yes,
to
ma'am.
interrupt. I guess there is some time constraint. You need to fast forward the process.
Yes, ma'am. Okay, ma'am. Okay, ma'am. So this is energy saving. So finally, what I am did the lab means I given to the brief explains on videos. Thank you.
I think Mr. Ganeshan has to present his slide. So he has to present his slide. So M2 batch can play the last slide for one.
So can I present, sir? I am Dr. Ganeshan.
Yes, sir. Please present.
So good morning to all of you. So I am Dr. Ganeshan from Dr. MGR Education and Research Institute. So my topic for the today's presentation is balancing of rotating masses. Okay, so All of us know that balancing of masses is very important, and especially for the rotating equipments and rotating members. And we come across various rotating that is equipments in industry also. So, for example, a shaft is always attached with some rotating equipments, rotors, flywheel, or it can be a gear. So that like that, various members are attached to a rotating shaft. So due to which the centrifugal force is created by each mass, and also if the masses are kept at different planes, then again the couple also come into play, and because of that there will be unbalance in the system. So the balancing is very much required. So if the member is not properly balanced, it will cause a lot of vibration and also noise, and in effect that will damage the equipment in long run. So whenever you have any equipment and where you have a number of rotating members or rotating equipments, it should be properly balanced. So today I am going to tell about the balancing of rotating masses, the number of masses in a single plane. So the experimental procedure is simple. So we know that whenever number of masses are acting along the same plane, always each mass will produce a centrifugal force, which is shown by this diagram. So there are I have considered M1, M2, M3, M4, like that. Four masses are kept on a rotating shaft along the same plane, and when the shaft is rotating, so each mass will produce a centrifugal force, namely M1R1 omega square, M2R2 omega square, like that. And this centrifugal force will create an unbalance. So to nullify the effect of the centrifugal force, what we have to do, we know always that there are number of forces, number of masses acting on along the same plane on a rotating shaft. So there is always a resultant force. So we can find the resultant of all these forces. We can resolve all the forces, and we can find the resultant force. So the resultant force is nothing but the net effect of all these disturbing masses. So just a simple principle is when you apply an equal and opposite force to the resultant force, then the net force acting on system will be zero. So for perfect balancing, we want the net force acting on the shaft should be zero, for which the resultant force has to be nullified. So that is a simple principle we are using. So what we are doing is we are first finding the magnitude and direction of the resultant force, and we are just applying the equal and opposite force. So for which here MB is the balancing mass at a particular radius we are keeping. By that way, the total system is balanced. So next slide. So this is a method of the resolution of the forces. So there are two methods. One is a graphical method. The other one is analytical method. So this shows the graphical method. So in the previous slide, in this slide also I have shown the direction of each mass. So mass M1 is acting horizontal, M2 is acting at theta 1, and like that at different angles the various masses are kept. So what we have to do is we have to represent the each centrifugal force by a force vector. So for example, the centrifugal force created by M1 is M1R1 omega square, that is represented by this vector. Similarly, the force created by M2 is M2R2 omega square, that is represented by this vector. So these vectors are to be drawn parallel to the direction of the mass. So M1 is kept horizontal, so I have drawn a force vector horizontally. Similarly, M2 is acting at this angle theta 1, same theta 1, you can draw this line, that is just parallel to this line, you can draw a line here. So also for the M3 and M4, you draw the force vectors. So this is the end of the force vector, and what we have to do is we have to close the polygon. So this is a force polygon which has to be closed, and the closing side will give the resultant. So this is the resultant direction. So resultant direction will be opposite to this. So the balancing mass should be kept in this direction. That is opposite to the resultant. So from that we found that this dotted line shows this direction of the balancing mass. So parallel to this, I have drawn a line here. So that shows the direction of the balancing mass. So what I have to do is I have to keep a balancing mass MB at a radius of R, so that the force created by this balancing mass is equal to the resultant force of the whole system. So that is a simple concept. Similarly, the other one is analytical method, where what we are doing is we are resolving all the forces horizontally and vertically, and these horizontal forces, horizontal force created by all these masses M1, M2, M3, M4, the summation of this mass should be equal to the balancing force. That's what I was telling. So you are equating the horizontal force to the horizontal component of this MV. Similarly, the vertical sum of the vertical components you take, that is sigma V, that should be equal to the vertical component due to this mass MV. So that is also another method by which you can equate. You will have two equations and two unknowns. The two unknowns are what is the balancing mass and what angle the balancing mass is to be kept. So using this, you can get the balancing mass and the angle. So this is the way of conventional method of solving that is balancing of several masses acting along the same plane. So which also can be validated through a virtual lab. So, in the virtual lab, I have considered two masses rotating along this, kept on the same plane of a shaft, and so that problem I have worked out with the conventional method, and I have found what is the value of MB and what is the theta, and I have given that value here, and I found that in the virtual lab it comes to close to the value, maybe around 0.5 to 1% error was shown there in the solution. So this way, it will be very useful for the students to work with the virtual lab and to validate the result. So it is very easy to get the result using the virtual lab. So normally we used to find the values through the analytical method or graphical method, and such thing can be validated through the virtual lab. So this is the link for the YouTube link for the virtual lab experiment I conducted. Can I open the link, sir?
Right now, due to time constraints, I guess we'll see that later, sir.
Okay, okay. Thank you for the opportunity.
Yeah, thank you. So I guess if mechanical team is done now, civil can start. That is first group, that is CE1, can start with their presentation.
So good morning all. So I am Narmada from Dr. Emchar Institute. So now I will start my sharing. Can you able to see me?
Yes, ma'am, you can proceed.
So group CE1, so assigned in a track 3, so belongs to civil engineering domain. So in our group members, we have 5 members. So I am the first person, Dr. M. Narmada from Dr. Emchar Educational Research University, Chennai. The second person, Vandana ma'am from KCG College. Then Subulakshmi ma'am from Sai Ram Engineering College. Then Dinesh sir from Nanda College. So finally, the Dr. M. Uma Mageshwari from REC. So we have the 5 members in our group. Aishwarya Shetty ma'am, our mentor. So thanks for guiding for everything, ma'am. Thank you so much. So in our group, we selected the marine structure lab by NIT Karnataka. So there is so many labs or the experiments are there. So I selected the first one, concrete mix design. So before that, we will enter the concrete mix design. So I would say, what is the importance of concrete mix design in the concrete world? So in every civil engineers, first they know the details in mix design. So in this experiment, so the main concept is the basic data are according to the IS 456. So the second part is during the mathematical calculation, we derived all the ingredients present in the concrete mix. So, so in this process, it is divided into 6 parts. The first one is, the first step is whatever we select the first concrete design mix. So second one is according to the target strength formula, we calculate the target strength. So the standard deviation, the S values from the S code. So then we concentrate the water cement ratio. Then the next step, we find out the water content. Then volume of coarse and fine aggregates. Finally, the volume of all the ingredients, will find out the basic on the formula. So now I will using the simulation in the lab. So I will explain that. So this is the formula.
Ma'am, we can proceed with the next participant. A video can be played.
Okay, ma'am.
after.
Okay, ma'am.
Yeah, thank you.
So, okay. So now we will move on next, ma'am. Uma Mageshwari, ma'am.
Yes, ma'am. Now I'll share the screen. You please stop your screen. Ma'am, you're able to see my screen?
Right now, no, ma'am. Did you share the screen?
Just a minute, ma'am.
Yeah.
The presentation के लिए
Yes, ma'am, your screen is visible. You can go ahead.
Page number 4, are you able to see, ma'am?
Yeah, we can see.
Yes, ma'am. Actually, I took this experiment. The name of the experiment is standard consistency and initial setting time of the cement. Now I'll introduce, that is introduction of these experiment is, that is the standard consistency test is actually, it is conducted to determine the amount of water to be added to the cement to get the paste of normal consistency. And actually it is used to fix the amount of water to be mixed in the cement for doing tests like setting time, soundness, and compressive strength. And also it is having one more experiment, that is initial setting time. On that, why actually it is we are finding the time, that is the duration between the moments that the water is added to the cement and the time when the paste start losing its plasticity. It is very important to know the setting time, because the process of doing like mixing, transportation, placing, and compacting and finishing should be completed within that specified initial setting time only. So now we'll see what are the aim of this experiment is to determine the standard consistency and initial setting time of the cement sample by VCAT apparatus. So this is the apparatus. Through this only we are able to determine both the standard consistency and also setting time. Here for the standard consistency we have to use this plunger, but for initial setting time we will use the needle. How to process this experiment is, that is for the standard consistency we have to take 300 grams of cement, and we start with the initially the percentage of water is 68 percentage of water by weight of cement. Then it is mixed and it is filled in the mold, and then we have to keep this plunger on the surface of the mold, then release it so that this plunger will penetrate into this mold which contain the cement paste, so that we can see the reading. uh, so we have to note down the that is reading. That reading shows that that is the height which is from the base plate, that is from the base of the mold to what is the height we have to note down. Suppose when the value is between the reading is 15 to 7, that is here it will show 33 to 35 mm. That is the percentage of water. That percentage of water is the standard consistency. Initially it will not come, we have to do some trial by increasing the percentage of water, like by increasing 2 percentage, on which percentage of water it comes, that is the standard consistency. So that is the input for the other test, like initial setting time, that is setting time, then soundness, compressive strength, like that. But here we are seeing another one test, that is initial setting time. Here we are using that consistency, that is percentage of water, that is 85 percentage of that standard consistency amount is amount of water is used. Again the sample we have to take the same 300 mm. We have to take the water and we have to add it in the cement. On that moment, we have to start the stopwatch, and we have to mix it within 3 to 5 minutes. The time should not be less than 3 minutes, and also it should not be more than 5 minutes, and it should be filled in the mold. And here we have to change the needle. That is, instead of plunger, we have to here insert the needle. Again, we have to note down the readings. Initially it will goes to 0. That is, for after some time it will get the reading around 5 to 7. That is, for each 5 minutes we have to note down the reading on which time when the reading it shows it is 5 to 7 mm. The time duration between the amount of water added to the cement to on which time the value is between the reading is between 5 to 7, that is the time, is the initial setting time. um, the next thing is simulation. Actually, what is the difference in what students are doing physically and also in the virtual lab? See, in the virtual lab, students can do anywhere and anytime, but in the lab there are some restrictions also. Again, individual students can do in the virtual lab, and also each and everything like weighing of the cement, even to keep it tar, make it a 0, everything is there. Sometimes students may miss those point and all. In the labs they did some mistakes. Here that is not at all possible. Suppose if students already did here, then they are done physically, and also it is very much useful for the student. They will do the that is experiments, will not only this, all the experiment, and also in between the questions which is coming on, that is also helpful the students to motivate to do the experiment and also learn more. uh, I just here I uploaded my video demo of this experiment. Thank you.
Thank you, ma'am. I guess the next one can take over.
Now I'll stop sharing.
Yes.
Yes, thank you.
Good morning, everyone. This is Dr. Vandana. Am I audible?
Yes, ma'am, you can proceed.
Thank you. Dr. Vandana from KCG College of Technology. I'm heading Civil Engineering Department. I'll be sharing my screen.
Yes.
Are you able to see?
Yes, ma'am, your screen is.
Fine. Okay. So I have taken up the experiment fineness modulus of cement and aggregates. So the main aim of the experiment is we'll be determining the fineness modulus of cement as well as for aggregates, coarse aggregates and fine aggregates, and we'll be evaluating the effective size, uniformity coefficient, and curvature coefficient by conducting this experiment. In fact, the theory, other things are explained in detail. I was a little surprised when I was viewing this. Currently, for third semester civil engineering students, we are having a lab, a laboratory named Construction Materials Lab. And we also have a theory paper on the same course. And in fact, during this pandemic and because of this virtual mode, I was a little bit worried. How are we going to conduct this laboratory? But yesterday, when because all these are coming under the title Marine Structures Lab. Though we are all civil engineers, we don't enter into this marine structures at all usually. But anyway, we found all these experiments, whatever listed out in the construction materials lab has been listed out in the marine structures lab also. And then, so looking at the simulation part, I was little surprised, I would say. Right from weighing and other things, everything is simulated so that the student can understand it much better. And the theory part is also explained properly. The procedure is given, and this is what I was saying. So how to switch on the weighing balance also it is given. So I was very much surprised and happy to know how this weighing everything is done. And we used to place the sieves and fan in the sieve shaker, and it will be doing the shaking for 15 minutes. So all those stuff has been explained properly and neatly so that the student will be able to understand and how we are going to collect the residue and what is the formula to be used. In fact, we can feed some data and check the formula and obtain the result also. So all this stuff has been explained fantastically in the virtual lab. I was very much shocked and surprised, I would say. And definitely, since I'm handling the theory part of construction materials, so all these laboratories definitely will give you a good idea about the cement, what are the tests to be done for cement, and with regard to the aggregates also. So we'll be determining the finest modulus of cement by using the seam shaker. And the video link is here. I don't want to take much of your time. Thank you all. Thank you so much. Can I stop sharing, ma'am?
Yes, ma'am, you can stop sharing. Thank you for the presentation.
Thank
I guess, yeah, I guess the next one can proceed. If group 1 is done, I guess we can proceed with the group 2.
Madam, I am member of group 2,
Yes.
Gangai Mani. So I am team leader is Velumani. Dr.
Yes.
Velumani sir, are you here?
I'm here only. Good morning, sir.
Good morning, sir. Very good morning.
Good morning. Sir, ready to share the screen. Shall I share the screens, ma'am?
So you can share, sir.
Okay.
Yes, sir, your screen is visible. You can proceed, sir.
Okay, thank you, ma'am. This is Velmani from KS Rangasamy College of Technology, Tiruchungur. My team name is Civil or CA2. My team members are Dr. Jilis Babu sir, Associate Professor, Mercos, Sadak Engineering College, Sivagasi. Then Dr. Kangai Mani sir, Associate Professor, MEM College of Engineering and Technology, Trichy. Then Dr. Vasanthi ma'am, Karange Karnataka Institute of Technology, Kanpur. My mentor is Aishwarya Shetty ma'am. Thank you for the motivation right now. This is my lab details. We have handed two labs. First one is fluid machineries labs, then mining geology lab. Fluid machineries lab is starting from myself is going to handle that lab. Then Kaplan turbine, the lab is going to Jilis Babu sir is going to handle the lab. Centrifugal pump, Dr. Vasanthi ma'am going to handle this lab. Mining geology lab, Dr. Kangai Mani sir going to the identification of minerals for that lab. The virtual laboratory is one of the on-screen calculator that learners use to test idea and observe the results. They allow the learners to think with laboratory equipment that will carry in them almost the same way as it was in a real environment. Make sure the virtual lab are accessible to the students. This is I'm going to handle the exploiting pump. This is the under category of marine engineering laboratory. Exploiting pump is the energy mechanism is the mechanical energy converted to hydraulic energy. by running in the input into the filter in the system of this storage. The cylinder, the piston, the cylinder will have a piston rod, connecting rod and the tank. The distributing pump can have a suction pipe, delivery pipe, and suction valve and delivery valve. The position of the distributing pump is the distributing pump, then set the speed motor of the consistent turning the column. Take the delivery pipe and then reading corresponding to the discharge. Consider the pointers by turning the wheel and get the delivery point recording the determine the start. The most useful for engineering and critical lab is the most useful how to working in the software and this is my video link. Next I move to hand over to Dr. K.S. Miss from Associate Professor for Engineering College for that. Sir.
Thank you very much, sir. Whether my voice is audible?
Yes, sir, you can.
Yeah, thank you. I will explain about the Kaplan turbine. And in general, turbine is something like the pump. The job of the pump is to convert the mechanical energy into hydraulic energy. On the other hand, turbine will convert the hydraulic energy into mechanical energy, which will be further converted into electrical energy by means of generator. And there are numerous types of turbines, and among them, the Pelton B, Kaplan turbine, and Francis turbine are the popular ones. And luckily, the virtual lab included all these experiments besides the pump. Here, I am not going to discuss about the simulation part of the pump, the turbine, as it is already shared through the video demonstration. And this particular Kaplan turbine is an axial flow reaction turbine. That means axial flow turbine means the flow of water through the runner is along the axis of rotation. And the reaction turbine means the energy available at the inlet of the turbine is in the form of pressure head and velocity head. And at the outlet, the energy available is only in the form of pressure head, that too the negative pressure, that is to virtually enhance the head available across the turbine. This is the concept behind the Kaplan turbine, and the aim of this particular experiment is to conduct the performance test on Kaplan turbine under constant head and to plot the operating characteristics. The simulation model is well prepared and it includes most of the things necessary for the students to get understood on their own. And I have added a couple of comments here, not to criticize the simulation model, but sometimes in future the developers can account these facts and ultimately the students can get benefited. That's the idea of pointing these 2 points. Like different values of head, if you look at the simulation model, there is a provision to choose the head values from the list. From that, the student or the user can choose the values. Similarly, if possible, the provision to adjust the inlet valve, that is the quantity of water that is going to strike the runner as well as the load on the fan. If the provisions are made for those parameters also, that will be good. It will give somehow more realistic feel. Here, if you just click the ball, it rotates somehow, it rotates and whatever may be the number of experiment, it shows the speed of the runner as 2750. That means if it is possible to adjust the inlet value, it will give somehow more realistic feel for the user who is doing the experiment. And the animation part, how the water flows and how the head rises, is given only for the actual discharge. It would be very good, it would be fine if such kind of animation is added for all the parts or all the steps. And I have included the video link here, and I take a moment to thank the organizers and my management for becoming the part of this virtual lab FPT program. Thank you.
Thank you, sir. Now the session going to handle for the Dr. Vasanti ma'am.
Yes, sir.
Vasanthi ma'am?
Yes, sir. Good afternoon to everyone. I chosen the laboratory regarding performance characteristic of centrifugal pumps. First of all, the aim of this experiment may be to conduct a performance test on centrifugal pump and to plot the operating characteristic. And then regarding introduction about the theory, the centrifugal pump, it is a rotodynamic machine and that imports energy to fluid by rotating impeller to increase the pressure of a fluid. So these pumps are commonly used to move the liquids or water through a piping system. So when the fluid enters the pump impeller along or nearer to the rotating axis, it is accelerated by the impeller and flowing radially outward into a diffuser from where it is exit into the downstream piping system. So commonly these centrifugal pumps are used for large discharge through smaller heads. The fluid enters the inlet of the centrifugal pump under the atmospheric pressure and flows into the eye of the impeller. So the centrifugal force exerted on the liquid by the rotating impeller and moves the liquid away from the impeller eye and out along the impeller base to their extreme tip. So where the liquid is then forced against the inside walls of the wallet and out through the discharge of the pump. So this is the theory regarding the performance characteristic of centrifugal pump. So basically I'm an agriculture graduate, so I don't know much more about this lab. So sorry guys, thank you.
Thank you, ma'am. I guess you have given a good presentation. I guess the next sir can present it.
Thank you, ma'am.
Now screen sharing to the Dr. Kangi Minister. Kangi Minister, you can please
share my
sorry. Kangi Minister.
So please share your screen, sir.
Kangi Minister, Kangi Minister, share your screen, sir.
So due to the time constraint, the session will be ended at 12. So it will be better if you start presenting now. I guess group 2, you can end your presentation.
Kangi Minister only have screen sharing, but he not have the screen.
So we can end the session right now. I guess it's already 12. We need to leave this room and move to the main room. So I guess we'll be checking his presentation later.
Okay, ma'am.
Yeah. So I guess thank you for everyone for your presentation. It was really great, and your time and efforts were seen in the presentation. So we would like to thank you all.
Ma'am, that presentation is over. All the presentation is over. This is Robin from PALS.
Drop a mail to us. So thank you. You can leave this room right now and move towards the main room.
Okay. Participants, I request the participants to leave the room and join in the main room. There will be a button, leave room. You click the leave room, then it will redirect to the main room. Dr. Paramasivam, Dr. Arivamani Ravanan, Dr. Ramachandran, please leave the room and join in the main room.